Okay, lesson 2 of limiting reagents. So it's not super common that you're going to be given an easy problem where you have 2 moles to compare, because you can't really do anything with moles. You can't weigh a mole unless it's a mole you caught in your backyard, because they're annoying. But the next types of problems are much more realistic, and that's if you're given 2 masses and you have to solve either which is the limiting or a subsequent problem from that. So here's an example of one such question. 10 grams of copper reacts with 20 grams of silver nitrate solution in a double replacement. What is the limiting reagent and how much silver metal is produced? Now, you can't just say, aha, that's the smallest number. No, it doesn't work that way. There is a little bit of work that we have to do. So I'm going to go over only 2 examples today. And the first example, I've already done the reaction for you. Oop. Okay, so here's the reaction. We have 10 grams of copper solid reacting with 20 grams of silver nitrate, and we need to figure out how many grams of silver that we've made. Now, the problem that a lot of people get into is they don't really figure out how to do limiting reagents, and they get a question like this, and they're like, how do I even do this? Normally, we only compare 2 substances. Why am I given extra information? Well, the idea is that once you find the limiting reagent, we don't care about the excess reagent's values, but we have to do a little bit of math to figure out what the limiting reagent is. So that's the first step of this, is to figure out what the limiting reagent is. Okay, so here's the first step. Now, we have to find the moles of both substance. And then we have to compare the moles like we did in the last unit by dividing it by the moles by the balance coefficient. We divide the copper by 1 and the silver nitrate by 2. The smallest value is the limiting reagent. Now, there's a shortcut I'm going to show you guys to get moles really quickly, and it's a formula. It is number of moles is equal always to mass over molar mass. This is the fastest way in questions like this to quickly calculate moles. Now, you'll see I already calculated the molar mass for both of these substances. So I'm going to go 10 I don't need to go 10.0, but 10 divided by 63.55, I get 0.157, we'll go 3 mole, and then 20 divided by 16988, and I get 0.11773. Okay, mole. Now, I need to do one more step and compare these moles fairly. Just all we've done is we've got to the point that we were in the last lesson where now we have moles to compare to. So I'm going to divide this by 1 and I'm going to divide this by 2. Now, obviously which number is going to be smaller, right? This number is going to be even smaller than this number. So my limiting reagent in this case is the silver nitrate. I'm going to run out of silver nitrate before I run out of copper because it has the smallest amount of chemical moles available to the reaction. Okay, once I've found the limiting reagent, I actually don't need the excess for this problem because now I'm going to be comparing these 2 substances. And from here on, it's just like any other stoich problem. We need to solve for mass comparing 2. So that's all. Now we've got what we need. Okay. Now I'm going to show you guys. I'm going to get rid of these notes here, so I have some room to work. Okay, get rid of that. So I have some room to work. Now, because I'm comparing these 2, we need to set it up just like a normal stoich problem. If I'm solving for mass, what goes with mass? Molar mass. I have 107.87 grams of silver for every mole silver. Okay, and because now I'm comparing those, I have mole ratio. 2 mole silver over 2 mole silver nitrate. Okay, This question wants mass of silver, so I'm going to start with the molar mass of silver. 107.87 grams silver per mole silver. Okay, that's used up. How do I get rid of mole silver? I'm going to use the mole ratio. 2 mole silver over 2 mole silver nitrate. Now here's the cool thing. Guess what I've already calculated? The moles of silver nitrate. I don't need to do mass and molar mass. I can, but I've already calculated the moles of silver nitrate. So I just need to put those in there. Now I probably should use the whole number on my calculator to make sure I'm really accurate. And it's done. Look, it's a little shortcut. Because we've calculated moles, we don't need to use the molar mass, moles, and then the mass to cancel it out. We've already got the moles of silver nitrate. And we're done. So now I just need to calculate that all out. And I get 12.7. That's my final answer. So I make 12.7 grams of silver. Now, had I used copper, I would have the wrong amount of moles, and I would predict incorrectly the amount of silver I would produce. Okay. So find moles, and then compare them by dividing by the coefficient, and then solve the problem. Now, there's a little bit of a trap that happens here. If you do compare them and you divide, you never use the divided moles right here. You always use the original moles from going mass divided by molar mass. We're only dividing to compare. Okay, one more. We've got 26.8 grams of silver chloride, and that's reacting with sodium hydroxide. Both are in solution. What mass of precipitate is made? Okay, so we got to write out a reaction. Iron 3 chloride is in solution. Sodium hydroxide is in solution. It's a double replacement. We get sodium chloride, pretty sure that's soluble, and iron 3 hydroxide. Okay, pretty sure that's our precipitate, and it is when I check my table. Balance this out, I need a 3 there. Okay, we've got 26.8 grams of iron chloride, and we have 21.5 of sodium hydroxide. And we need to figure out the mass of precipitate. Now, before we can do that, we have 2 different masses. We've got to figure out what the limiting reagent is. So I need to figure out the molar mass of both of those substances. So iron chloride, 55.85, and 3 chlorines. I have a molar mass of 162.2 grams per mole. And sodium's, I think, is 40. I think I got that one memorized. Mr. Zielinski has a lot of them memorized. Yeah, it's 40 grams per mole. Okay. Now let's use that formula. Number of moles is equal to mass over molar mass. That's that shortcut to get number of moles. So 26.8 divided by 162.2, I get 0.16522 moles. Okay. 21.5 divided by 40, I get 0.5375 mole. Okay, now I have to compare these fairly, right? These are my 2 moles. I have to compare these fairly. How do I compare them fairly? I divide by the coefficient. So I'm going to divide this one by 3, and I'm going to divide this one by 1, because this is balanced for 1, and that's balanced for 3. So that's going to be the same number, right? So 0.5375 divided by 3 gets me 0.179. So this is still a bigger number than this. This is my limiting reagent. That's my limiting reagent. I'm going to run out of the iron chloride first. So even though it had more mass to start with, its mole amount, when compared fairly, was the smallest amount. So that means really I don't need to use anything from the sodium hydroxide value. Now, the second part of this question is I need to solve for the mass of iron hydroxide. So now it's a normal stoichiometry problem where I have two substances to compare. So I need the mole ratio between them. I have 1 mole of iron hydroxide, right? Mole ratio is always one of the things we use, and 1 mole of iron chloride. I also need the molar mass of iron hydroxide. So quite quickly, I have 106.86 grams iron hydroxide per mole iron hydroxide. Okay. Now, what do we start with? Well, we're trying to solve for mass of iron hydroxide. So I'm going to start with the molar mass of iron hydroxide first because that has the mass variable on top. 106.88 grams iron hydroxide over mole iron hydroxide. Okay, used up a variable. I got to get rid of moles iron hydroxide, so I'm going to use the mole ratio of iron hydroxide. 1 mole iron hydroxide over 1 mole iron chloride. And how do I get rid of moles iron chloride? Well, look what I've calculated over here. Look at this shortcut. That's iron chloride. That's the moles of iron chloride. So little shortcut. I can go 0.16522 mole. Oh, I ran out of room, whatever. Over 1. That cancels. That cancels. Okay. So that's a cute little shortcut. Can save us a lot of time on kind of an annoying problem. All right, so final answer is 3 sig fig 17.7. Okay, perfect. All right, so let's recap. If you're given a question like this, you have to do, the first step is write a reaction. The second step is figure out, if you're not given, the molar masses of the substances. The third step is to go mass divided by molar mass and get their moles. And then compare the moles equally by dividing them by the coefficient they're balanced for. Now, you can maybe do that in your head and say, oh, okay, obviously if I divide this by 7, it's going to be the smallest number. The limiting reagent is then the substance that you use to compare to the substance you have to solve for. Now, that, as you can see, we don't really need to use that anymore once we figured out what the limiting reagent is. Okay. So you'll see that there is going to be an assignment that goes with limiting reagents. We're not starting that till Monday next week because there's one more concept of limiting reagents I'm going to go over tomorrow. So I've made a 3-question Google form so you can try this if you feel up to it, if you want to. Tomorrow, once we have all of the knowledge on limiting reagents, I'll release the assignment. So those of you who are a bit working ahead or want something to start can start that on Friday. That assignment is going to be our week's work next week. All right, that's the lesson for today, guys. Limiting reagents, mass and mass.